Yo, Zinthaspace here, and I'm back with another epic math video. This is in fact my second math video on the Zinthaspace channel, and I will be making a video on the golden ratio. Now, I just want to go over something that's real quick. In my last video on what I to I equals, I explained how Euler's formula works. E to the x equals cosine x plus, e to I x was I sine x. That also means that this is kind of a, I'm just going to scoot my camera over a bit. There's this kind of like famous thing in math called Euler's identity, which says that e to the I pi plus 1 equals 0. The reason why is because the cosine of pi is -1 and the sine of pi is 0. Thus, e to the power of I pi plus 1 equals 0, because e to the I pi is -1. Now, let's get into the golden ratio. Now, if you don't know, the golden ratio is the ratio of the sides of a rectangle so perfect they can divide it into a normal square and then another golden rectangle. And you can do it again and again and again and again and again. And if you actually sort of trace these boxes with the curve, you actually get the golden spiral, which you can actually see inside of some plants, yes, nature does actually use the golden ratio sometimes. Now this side here is 1. This is also 1 because this has to be a square here. And then this is the golden ratio, or phi. You write that with the Greek letter phi. This bit here is just phi minus 1. Now, in order to split it like that, that means phi, which is the ratio of the sides of the rectangle, equals the ratio of 1 to phi minus 1, which is, actually pretty cool, because if this is another golden rectangle, that means the ratio of phi to 1 equals the ratio of 1 to phi minus 1, if that makes sense. I don't know if that makes sense. I do know that lots of my viewers on the I to the I video didn't watch until the end because it was too complicated for them. But anyways, the next part is to you actually, now you multiply by phi to get phi squared equals phi over phi minus 1. Wait, no, that's... No, that's not what you do. So I think first what you do is you take the reciprocal on both sides. So 1 over phi equals phi minus 1 because of the properties of the rectangle, which however does mean that phi equals phi squared minus wait, what? Sorry, I'm just... So actually, I think first we need to rearrange this to say that. So I think if you actually do a little bit of algebraic rearranging, you'll get that. Well, actually, no. I mean, you just multiplying by 5 here. So 1 equals 5 squared minus 5, which means 5 squared minus 5 minus... Oh, you need to see that there. Minus 1 equals 0. Gosh, I really am having trouble with, moving the... There's a little bit of garbage on my desk I had to, move. Now, this means that 1... Also, 1 times 5 squared plus negative 1 times 5 plus negative 1 is all equal to 0. If you haven't... So, yes, we are actually going to use the quadratic formula. So, A equals 1, B equals negative 1, C equals negative 1, 2. So what we need to do is do negative b plus or minus the square root of b squared minus 4ac, all divided by 2a, which means, well, negative 1 plus or minus the square root of negative 1 squared plus minus 4 times 1 times negative 1, all divided by 2 times a, which is 2. If you solve all of this, you get 1 plus or minus the square root of 5 all over 2, which this is actually what the golden ratio is. 1 plus or minus the square root of 5 over 2.